All right, so graphing piecewise defined function. So what a piecewise defined function is a function that can't be written with one equation. You see this a lot in real world applications because everything can't be described with one simple equation. But if we break a situation into pieces, we can write the equation of the different pieces and then create one function out of all of those pieces. And so that's what a piecewise defined function is. When we are evaluating and graphing them, the key to a piecewise defined function is actually the domain values right here on the right. This is telling you when to apply this part of the function. So for values less than 0, we are going to apply x squared plus 1. For values that are greater than or equal to 0, we're going to apply x minus 1. So it's very key that you're looking at this domain values when you're determining which piece of the function. You will never use both pieces of the function in the same problem. Okay, you have to choose one. Otherwise, you have repeating x values, and that doesn't work. So let's look at this one. So according to this, they want me to find f of negative 1. Well, which piece of the function does negative 1 fall into? Well, negative 1 is less than 0, so it's going to fall into the piece of the function x squared plus 1. So what does that look like? That means I'm going to plug negative 1 into that piece. So negative 1 squared is 1 plus 1. That means f of negative 1 is positive 2. All right, let's do f of 5. Well, where does f of 5 fall into this function? Well, 5 is greater than 0, so it's going to fall right there in the second piece, the bottom piece, x minus 1. So I'm going to plug 5 into x minus 1, and that result is 4. So what about 0? F of 0. Well, 0 falls into the bottom portion because that's where my equal to 0 is. X is greater than or equal to 0. And so when I'm plugging this in, I'm not going to plug it into both of them. I'm only going to plug into the piece where it's equal. So that's going to be 0 minus 1 equals negative 1. We can see this on this graph. This graph over here. This is the graph of this piecewise function. Notice we have a parabola here, moved up 1. We can see that it's just the left side, the part that's less than 0. And then at x equals 0, we start with the line x minus 1 that goes off to the right. So if you see, negative 1 is at positive 2. 5 is at 4. And 0 is defined at negative 1. Let's try another one. Let's evaluate this one. So we're going to try to find h of 1. So think about h of 1. Which of these domains will 1 fall into? Is 1 less than 2, between 2 and 4, or greater than 4? Well, 1 is less than 2. So I'm going to plug 1 into that particular piece, and I get 1 squared plus 3, which would be 4. Then where does 3 fall? Is 3 less than 2? Is 3 between 2 and 4? Or is 3 greater than 4? Well, 3 would be between 2 and 4. So when I plug 3 in, notice here, this one's a little bit special. Notice here, this one is 7. No x values. So h of 3 is simply 7 because I don't have anywhere to plug in my 3. And what about h of 4? Well, where is the equal to in this problem? Well, the equal to is right here on the middle. So this one also equals 7. Lastly, h of 5. Well, h of 5 is greater than 4, so we're on this bottom one. So we're going to do 2 times 5 minus 1. That's 10 minus 1 is 9. So how do we graph a piecewise function? Well, it's about graphing the two pieces. So I have two things I need to graph. I need to graph 1/2 x plus 1. I also need to graph negative x minus 1. So these are both lines. So think y equals mx plus b. We've graphed lines before. So I can graph them, first of all, first choice, I can graph them by doing slope-intercept. So my intercept here is 1. So I have the point 0, 1 on this graph. Then I have the slope of 1/2. On this equation, I have a y-intercept of -1, so 0, -1 is a point, and a slope of -1. But notice where my domain is. My domain is at 2, so my graph is splitting right here at +2. So I'm going to graph this on the less than 2. I'm going to graph this one on the left of that dotted line. I'm going to graph this one on the right. Now, you may think, well, my y-axis is not available for this point. Well, there's a couple of options you have. You can either use that point and then erase the part of the line you don't need, and I'll show you how to do that, or you can just find another point to work with. Okay, so I'm going to show you how to just graph it and erase what you don't need. So let's start with graphing this one. I'm going to graph this one in blue. So I have a point at 0, 1. There's my y-intercept. I have a slope of 1/2. So that's up 1 over 2. Well, notice that puts me on my dividing line. So the question I got to ask myself is, in x less than 2, if I'm sitting on this line, up 1 over 2, do I put an open circle or a closed circle? Well, that is not equal to. So here, I'm going to put an open circle. I can even count backwards just to get me another point if I want to. I'm going to draw my line that way. So that's the left side of my line. Now, I'll do the other one in green just to kind of let it stand out. So if I want to graph this exactly the same way, my y-intercept is at -1, and I'm going to count, I can count down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So my line goes that way. But my line doesn't need to start until this point right here because it's greater than or equal to 2. So what I'm going to do is I'm going to erase everything before that. So there's the graph. Now, if you don't want to do that, what you can do is you could plug, say plug 2, get my pen back. You could plug this value of 2, so -2 minus 1 equals -2 minus 1, which is -3, and I can know that that's the point where I need to start. Okay, so I could either find other points that are within my domain values, or I can graph the line and then erase the part that I don't need. Let's do one more of those. So I have 3 divisions here. I'm going to put them, I'm going to highlight them this time. So my divisions are, because they're not really part of the graph, I just do this to help know where I'm at. So 0 is one of the dividing lines, so I'm going to have a dividing line right there. 2 is a dividing line, I'm going to have a dividing line right there. So I've got 3 sections of this graph. The first section is defined to the left of 0, x is less than 0. That section is defined simply as -1. That makes it a horizontal line at -1. This does not have an equal to. X is less than 0, no equal to, so we're going to open circle at -1, and we're going to draw a horizontal line on the left side. So that takes care of that. Now, in the middle, I have x minus 1. So I have a y-intercept of 0, -1, and a slope of 1. And I'm going to draw this between 0 and 2. And notice both of those are equal to. So when I start graphing this, I'm going to shade the endpoints of this particular section because of the equal to. So 0, -1. Well, notice what happens here. That means that point that I had an open circle on is now part of the graph. And then I'm going to count up 1 over 1, up 1 over 1. And so here is the middle section. Notice that the green and blue line are actually connected. Okay, so we actually do have a point there. Now let's do the third section. For those points that are greater than 2, I'm going to graph the line starting at 0, 6, and a slope of -2. Well, notice I don't have a 6 up here. Notice that my graph stops at 5. So this is going to be one of those situations where I might want to just find a point. So let's plug in, say, negative 2 times 3. Negative 2 times 3 is negative 6, plus 6 gives me 0. So a point within my domain that I could use is 3, 0. So 3, 0. Now you're thinking, well, what do I do next? Well, now I'm going to count my slope, because I can go down to right 1, or I could go up to left 1. And remember, this is not equal to, so I'm going to put an open circle. And there's the line for that piece.